All right, in this video, I'm going to be going over how to graph the cube root functions, okay? I'm going to try and make this nice and easy. So graphing the cube root functions is just like graphing the square root functions. You kind of want to find the perfect cube. So like the cube root of 8 is 2. You know, we don't know the cube root of 2. It's irrational. The cube root of 1 is 1. Cube root of 0 is 0. And the difference with square roots is that you can actually take the cube root of negative numbers. So the cube root of -1, is -1. The cube root of -8 is -2. So looking at all these numbers right here, you notice that these are all the numbers where we can take a cube root and get a whole number. So just like with square roots, those are kind of the numbers that you want to put in your table, all right? The perfect cubes, as we say. And it's kind of easier than square roots. You only have to remember 3 of them, 0, 1, and 8. And then you just know that then you have -1 and -8, all right? And so those are kind of the numbers that you want to put in your table because you want to graph whole points, right? So, we can write down the cube roots of these numbers. Cube root of -8 is -2, -1, 0, 1, 2. And so you've got this like group of points that you kind of want to remember, okay? And so what you're going to do, you're going to graph them on here. So you're going to have a point at 0, 0, and this is for your parent function, okay? And then you have a point at 1, 1, and -1, -1. So you got those 3 points there like right in a row, right next to each other. And then you have 8 and -8, and both of those go to 2 because the cube root of 8 is 2. So these are the 5 points for your parent function. And if you know these 5 points, then it makes it really easy to graph because you can just kind of move this around, okay? So this point in the middle at 0, 0 is what we call the turning point. It's the point where, the cubic, like, kind of, slides like that. Domain and range for cube roots, super easy. It's always going to be -infinity to infinity for both. So you should never get this wrong. Because if you look, all right, we got arrow on the left, arrow on the right, and then also arrow going down, arrow going up, all right? So it doesn't matter what transformations you have. This is it. Speaking of transformations, we have the same transformations that we had for square root functions. We got, A, H, and K. You can read here what they do. And, this same thing as square root functions, okay? So, it doesn't matter. You still got a number out in front. That's your A value. So this would be like a stretch by 4. This number is outside of the square root sign, which means it's a K value. So that means down by 1. You can do the other two. This is exactly like square roots, what we went over yesterday. So I want to get to the graphing. So there's 3 graphing questions that we're going to do. And number 1 is just a simple reflection and nothing else. So that negative sign, remember, that means reflection. So what we want to do, all right, for most of these is just graph the parent function, okay? So we've got 0, 0, 1, 1, -1, -1. You remember you got those 3 points. And then your other 2 points are at 8, 2, and -8, -2. And you can always look at your notes if you ever forget that. Now for reflection, what that means is that we're reflecting everything over the x-axis, all right? So we're going to take the points up and put them down. So like this point right here, that's up 2. We're going to move that to down 2. This point's up 1, so we're going to move it to down 1. This point's down 1, so we move it to up 1. This point's down 2, so we move it to up 2. And this point here stays the same because it's on the x-axis. And so we just reflect it. Everything flips. And now we connect our points, and this is our cube root function. All right, so that's how you would do a reflection. You can kind of do a reflection first and move things around if you want. Turning point, since we didn't move it at all, still at 0, 0. And domain and range is always at -infinity to infinity. You can copy that and you can paste it and you can go put it for all of them if you want because it's not going to change. Number 2. So for number 2, we've got a stretch by 3. And then since that's inside the parentheses, that's an h value. So that means we're going to go right 1 because h is backwards. So again, what you should do here is plot your parent function points. 0, 0, 1, 1, negative 1, negative 1, 8, 2, and negative 8, negative 2. And what you're going to do here is you're going to stretch it by 3 and then move it all to the right by 1. Now, the stretch, so I kind of went through this with square roots yesterday, but what that means is that all your vertical distances are being multiplied by 3. So this point right here is up 1. Now it's going to be up 3 because 3 times 1 is 3. Similarly, this point's down 1, so now it's going to go down 3. Then we got our points on the edge. This point's up 2, so 2 times 3 is 6, so now it's going to be moved to up 6. This point is down 2, so now it's going to be moved to down 6. This point, again, is on the x-axis, so it doesn't get stretched at all, and it stays. And so those are all our points, and now we need to move it to the right 1. So you can just move them all to the right by 1. And again, kind of look at the turning point, right? The turning point is being moved to 1, 0. And then you can connect your points, and you've got your cubic or your cube root function, and you're good to go. Domain and range, just copy and paste, negative infinity to infinity every single time for both. So that's how you do a stretch. If it's a compression, if you're like multiplying it by a half, for example, you just shrink it. This one only has shifts. So we got this plus 2. Remember, that means left 2. And then we got the 1 at the end. That means up 2. So again, we're just going to plot our parent function, and then we're just going to move it. So we've got 0, 0. We got 1, 1, negative 1, negative 1. Then we go to 8, 2. Negative 8, negative 2. And now we want to shift it left 2 and up 2. So again, just kind of look at the turning point. That's the one you can focus on, and the rest, we'll move with it. So we go 1, 2, up 1, 2. And there we go. So our turning point got moved to negative 2, 2. These are going to be the same, so why don't we just paste them? And then we can connect our points and make our cubic function. All right, so that's how you graph a cube root. It's not really that difficult. If you have trouble, remember you can always use Desmos. All you have to do for this is, just type in whatever you want to graph. So 3. Now, for this cube root, you have to click on this button here that says Functions. And then you have to go all the way to the right tab, the one that's miscellaneous. And if you see this button right here with the n over top of the radical, that's a cube root. So you need to type the 3 up there to say what kind of root you want. And then whatever you want to type in the middle, type in the middle. So x minus 1, and here we go. We've got our cubic function that we graphed before. You can get those points, plot them on your graph. If you want to get more points, click the gear and then click the table symbol, and you can make a table. And, just kind of look at it, and you can kind of plot points. It's going to kind of go far. So for example, you kind of want to just keep going backwards until, you get to points. So there we go, negative 7, 6. There's a point. So you just want to keep guessing numbers until you get whole numbers, like here again, 4, 5, 6, 7. Oh, not 78. 8, 9. There we go, 9, 6. There's another point you can plot. Okay, so if you need Desmos to help you get points, you can use it that way. So let me know if you have any questions. You can always message me, and I'll try and send more detailed responses. You got just a very short practice, just like yesterday. Go ahead and try that, and that's it. So yeah, let me know if you need any help. And other than that, have a great day.